Shahin Pirooz will give the next presentation on automated cloud mobility. Shahin Pirooz is the CTO of River Meadow, a cloud service provider that specializes in cloud migration. Shahin Pirooz is responsible for overseeing and expanding the development and integration of River Meadow's cloud migration SaaS platform.
Hi, this is Shahin Pirooz. I'm the CTO for River Meadow Software, and I would like to welcome you to joining us here at the Business After Windows conference to talk about automated cloud mobility. Over the next 20-30 minutes, I'd like to talk to you about why it's important to consider moving your workloads to the cloud and how the BYOD movement and cloud computing are kind of fueling each other and effectively creating a snowball effect of one begetting the other. I'm going to talk about the need to break down the traditional IT walls and how you want to get ahead of the next wave of technology by taking your existing workloads, existing servers and applications, and SaaSifying them by moving them to the cloud. We take a look at the data here provided by Netscope. The BYOD movement is clearly moving quickly. Many of you out there, 74% of you out there today allow some form of BYOD at work for your employees. And then on the flip side, the employees, about 81% of them are saying that they use at least one of their personal devices to conduct business today. The implication here is that there's a significant portion of the workforce today that is consuming their work functions or performing their work functions on mobile devices, including tablets and the traditional phones, smartphones. On the right side of this screen, you'll notice that there's a significant movement of business applications that are being accessed from the cloud between January and October. You'll notice that on an average, about 600 apps are running in the cloud that the consumers are accessing over their mobile devices. What that means is that as more mobile devices, or the implication here is as more mobile devices come to the workforce, there's a need to expose your applications in such a way that they can consume them. And the way to do that is to put them on the cloud and make them accessible in a SaaS model. So by having more mobile devices, we have to provide cloud computing capabilities. By having more cloud computing capabilities, we're inviting our employees to bring their mobile devices to consume these cool new cloud services we had, which then begets more mobile devices, which then in turn causes us to react and expose more capabilities in IT services and applications in the form of a SaaSified application. So this snowball effect continues to happen where one begets the other. The more mobile devices, the more cloud consumption we have, the more cloud services we need, and the more we put out there, the more mobile devices show up. So what we end up having to do is to break down the traditional walls that we've created in IT that say that we've got these bastions hosts that we control and manage, and it's in our server room, we see the blinking lights, and we need to start thinking above and beyond that and making these applications available to these mobile devices so that our employees and our workforce can be more productive no matter where they are, whether they're sitting in Starbucks, at an airport, in a customer's office, or in our own corporate offices. They need to be able to consume the services that allow them to do their job day in, day out. So what do we need to do? We need to take our business applications and make them accessible from anywhere. Simple way to do that is to take those applications and SaaSify them and expose them on a cloud, on a public cloud, so that our mobile devices can consume them, and put some front ends, rich front ends in front of them to convert and create those applications or consume mobile services such that those applications can be consumed from a mobile device easily. Let's talk about an approach for getting from where we are today to breaking down these traditional walls. I'm going to first talk about the ways to take existing workloads from an existing data center or server room and moving it to the cloud. There's really three approaches. There's a fourth one, which is manual, and that one I won't really talk about here other than the fact that it's much more time consuming and expensive than any of these approaches. There are, to start with, in number one here, the template-based data movers. These guys instantiate a template in the target cloud environment, and this template could be a different version of Windows than the Windows server you're moving, or a different version of Linux than the Linux server you're moving. They install an agent on this template. They then go to the source server that's in your data center and install an agent on that. They plug those two together and do data replication between them. The implication is, first of all, the pro on this approach is that this is a technology that's been around for 20 years. We use these companies to do data replication, and we have for the last 20 years. So it's a well-known process that has had some success in terms of replicating data. The con here is, though, that because we're taking and synchronizing an operating system, two disparate operating systems, one that may be slightly back levels on patches compared to the other, there may be different DLLs running on them, and we're mashing these two operating systems together, we end up have a high failure rate due to that mashup because the end operating system isn't exactly the same as the source operating system, and that alone may be enough to cause the application not to work. These template-based data movers have a high failure rate when there's an application running on the server. The next category here is the application containers. These companies are taking and creating a wrapper shim, or platform as a service, around your application and any parts of the OS that that application needs to take with it. Oftentimes, you can't simply grab existing applications. You have to purpose build your applications for these container-based approaches, or be able to implement your application within these platform as a service models. Once this container is built, you can take this container and deploy it into a template operating system on the target side, which then implies that you're running a hypervisor within a hypervisor and taking all the negative implications associated with that. It is an application-centric approach, so that's a positive for this solution. However, you end up becoming tied to this particular provider and their longevity and solvency in terms of how well your app will succeed in the years to come. Most of the companies that are taking this approach are early stage, so that particular previous bullet is a high-risk bullet to consume. And a lot of times you can't take existing applications. You have to rely on their SDKs in order to be able to build applications associated with their template model. Finally, we come to the approach that River Meadow takes, which is what we call lift and shift, which is taking the operating system as is from the source environment and moving it, copying it to the target environment. We do this completely agentlessly without any software required to be installed on either side by you in the source environment, and no software required to be installed in the form of templates or anything like that in the target environment. It's completely automated. All we need from you is an IP address for the source server, credentials for the source server, credentials from the target. You enter those into the UI. They're completely encrypted and secured. And we simply reach across from the target cloud to your source environment behind your firewall. So it's as secure as fast as your environment and your firewalls are. And we move the server. We grab attributes, collect information, replicate the data. Because there's no software installed, because we're doing this as a live migration, it's risk-free. Because it's completely automated, it's much faster and cheaper. We can massively scale out. And the positive here is that we move your OS as is, which just happens to be the negative as well. We also move your OS as is. So if you're looking to do an operating system upgrade, this solution is just the first step in the process. But because we move the server completely risk-free without touching the source server, you can test your upgrades, test your modifications, test your configuration changes in the target cloud and determine if they work or don't work before you impact production. This platform is available for you to move servers, whether they are physical, virtual, or in another cloud. They could be in Microsoft Azure, they could be in VMware, they could be in an OpenStack cloud, and you can move from there to any cloud, and some samples of clouds that we support on the right from every flavor of VMware, including vCloud and vSphere, Oracle, Amazon, OpenStack, multiple flavors of OpenStack, and then from a hypervisor support perspective, KVM, Xen, and ESX. And the Microsoft Azure platform is also a cloud we support. So just about any cloud, from any source to any cloud. Let's talk a moment about how this process works. When you first reach out to us and provide the four things I told you about, the IP address, the credentials, and the path to the source server from the target cloud, we deploy a cloud appliance into the target cloud using the cloud APIs for that environment. that cloud appliance reaches across and gets the attributes from the source server. It collects what processors it has, how much memory, how much disk, and the model data that makes up that server. We leverage that data to, in our SaaS platform, model what we call a target worker that looks and feels like that source server. However, it has our appliance-based operating system. That target worker then gets pushed into the target cloud, wakes up, collects the data from the source. So this is a data replication like the traditional data replicators. It then takes, and after it's done with the replication, it injects the proper drivers, configuration, tools, and networking required for that server to work in the target cloud on top of that target hypervisor, and makes that conversion process happen, reboots, and then resets the boot sector to be the original system disk as opposed to our appliance-based disk. And we drop the appliance-based disk. At this point, you have an exact copy of your source server, and you've done nothing to the source server. It is still live, it's still operating, and this has been a completely risk-free movement of your server from your existing environment to your new target cloud environment. And again, that target cloud can be a public cloud or it can be a private cloud. Let's say you want to go from Amazon to OpenStack or ESX internally. Some of the features that come with this platform are that it's completely SaaS-based, which gives us the ability to do this without installing software. So no software for you to install, no software to download. It's all completely automated. It's built on REST APIs, so you can consume those APIs directly, or you can use our UIs to do all of this work. There is a role-based, policy-based, and multi-tiered organizational hierarchy within the application, so you can model the organizational structure to your business architecture, and you can set policies and rules based on who can do what and when they can do it. And because we collect all of the metadata around a migration, we give you a complete governance view of the world so that you can meet any regulatory or internal compliance requirements in terms of who did what, when they did it, and what servers were moved from where to where. Some features we have coming around the corner, which are some game changers in our opinion, are the differential migrations, which effectively are a capture of what has changed from one migration to the other, therefore allowing you to move a small amount of data between the original cutover and the final cutover, for example, or create the concepts of disaster recovery by doing a regularly scheduled migration and only capturing the changes. It's important to understand that differential migrations are purpose-built for this kind of cross-platform mobility, where a sync would overwrite any of the configuration changes, the conversion process I talked about. Differential migrations takes those into account and reapplies them after the differential sync. Binary assets are a feature that allow you to deploy executables or scripts, any form of binary asset that you want to have deployed and executed on the target machine, we can do. These could be things like removing particular software configurations, modifying configurations, and, for example, installing management tools in the target cloud. These can be fully scripted, so we can run any script you hand us that the system supports. The catalog assets are the next evolution of our Secure Direct platform, which will allow us to, rather than having to push the target workers and cloud appliances in through the cloud controller APIs, we will be able to consume the catalog, public catalog-based instantiations of those things and reduce the time to start a migration and get you more quickly to replicating data and being off the ground and running. Let's take a moment to talk about how all this works. We have the ability to move mass numbers of servers in concurrency, and the only limiting factor is the bandwidth in this case. Our platform is designed to massively scale out, assuming that there's network bandwidth to support the movement of the data. On the left side of this chart, you'll see the source data center, which is where your beginning source environment is. The right side is a target data center. This can be an internal private cloud, or it can be a public cloud that you're consuming like Amazon or Azure. And the top right of the screen is the River Meadow SaaS platform and our message bus, which allows the communication, secure communication between the cloud appliance in green and the target workers in red. What we do is the cloud appliance is really our control point within the target cloud that is there only throughout the migration cycle. And it instructs the target workers what they need to do. The target workers are paired one-to-one with the source servers on the left side of this diagram. And each of them will reach out to their respective pair, do the data replication, do the conversion process, the reboot and repointing of the boot sector I talked about in the previous slide. Once this migration is complete, you end up having a cloud version of your data center for those servers that you identified that you want to move. And you can remove our cloud appliance from this platform, and at that point there is no footprint of River Meadow left behind. So there's you are not tied to River Meadow's success. Your migration is complete, and you can continue operating as you did, but in the cloud today. And all of your existing servers stay up and running for you to be able to do testing and validation of the target side before you shut down the source environment and cut over. The value proposition for everything I just talked about is if we take a manual migration, which is an offline, shut down the server, do a P2V or snapshot, put it to disk, ship it to the target cloud, import it, ingest it, and run it, compared to the automated approach we just talked about, we are 10 times faster, 5 times cheaper, and 100% risk-free in that you don't have to shut down your servers. There's no change control process you have to follow, and you have the ability to do massive numbers of servers at the same time, assuming your bandwidth supports that. So this is a step in the direction of taking and SaaSifying your applications in order to expose your services and capabilities to your end users and get them the level of access they have today on their desktops and laptops on their mobile devices. With that, I'd like to wrap up and thank you for your time and open it up for a question and answer. Thank you very much.